Hello everyone and welcome back to another lab. Today's lab we will explore how address resolution protocol function in a network environment. ARP is a fundamental networking protocol that it used to map IP addresses to MAC addresses within a local network, and it plays a crucial role in facilitating communication between devices on the same subnet. By resolving IP addresses to MAC addresses, ARP enables devices to send data packets to the correct destination within the local network. So the objectives of this lab is to gain a thorough understanding of the address resolution protocol and its operation within a local network. And we are going to do that by verifying ARP on routers, switches, and PCs, and we will explore how ARP facilitates communication by mapping IP addresses to MAC addresses. So our topology for this lab is straightforward, which consists of two routers, router 1 and router 2, and a couple of devices that we can see that they are connected to switch 1, and switch 1 is connected to router 1. So we will be using class B from the RFC 1918 in this lab. And before we do the usual, where we go through the lab tasks and then cover the configuration steps, I would like to explain briefly why ARP is quite important. So ARP enables devices within a local network to communicate with each other by mapping IP addresses to MAC addresses. And without the ARP, devices would not be able to send data packets to the correct destination within the network. In local networks, devices rely on ARP to discover the MAC addresses of other devices on the same subnet. This is crucial for activities such as sending data packets or establishing connection and accessing network resources. ARP dynamically resolve IP addresses to MAC addresses as devices communicate within the network. This dynamic mapping allows for efficient and flexible communication between devices, even as network configuration changes over time. Not to mention that ARP plays a key role in layer 2 switching, where switches use MAC address tables, which is the CAM table, to forward data packets within the network. ARP helps populate these tables by mapping IP addresses to MAC addresses. So understand ARP is essential for troubleshooting network connectivity issues and diagnosing ARP-related problems. The network administrators need to be familiar with the ARP to effectively manage and maintain local networks. Okay, but you might ask me the question of, okay, how does it work? So when a device wants to communicate with another device on the same local network, it first checks its ARP cache, also known as the ARP table, to see if it already has the MAC address corresponding to the IP address it wants to reach. If the MAC address is not found in the cache table, the device sends out an ARP request broadcast packet to the network, asking for the MAC address associated with the target IP address. Upon receiving the ARP request, the device with the requested IP address responds with an ARP reply packet containing its MAC address. This reply is a unicast directly to the requesting device. The requesting device receives the ARP reply and update its ARP cache with the MAC address of the target device. It now has the necessary information to send packets directly to the destination device using its MAC address. Finally, the ARP timeout. So ARP cache entries have a limited lifetime, known as the ARP timeout. After a certain period of time, if there is no communication with a specific device, its entry may be removed from the ARP cache. When communication is attempted again, the device will need to perform a new ARP request to obtain the MAC address once more. It will then update the ARP table accordingly. Okay, now let's go through the usual, where I'm going to walk you through the lab tasks and then go through the configuration steps as per usual. So if I scroll a little bit down, you will be able to see the list of tasks as you can see on the screen. So the first task is basically building the lab according to the topology. And once you've patched all the cables, you can then move to the next step, which is going to connect to the CLI of each router and then change the host name to reflect what's on the topology. We then move to step number 3, where we are going to enable both interfaces on router 1, which are Gig Ethernet 000 and 001. We will also configure the description of each interface, and we are going to enable the interface on router 2, which is Gig Ethernet 000. Once we completed step number 3, we can then move to step number 4, where we are going to display the ARP table and try to observe the output if there is any. And from there, we can then move to step number 5, where we're going to start configuring some IPv4 addresses on router 1 and router 2 and our PCs as well. We then going to verify that each interface is in the up state. So the physical layer is up and the logical layer is up as well. And then we're going to move to step number 7, where we are going to look again at the ARP table and see if the router has updated the ARP table. And then we're going to verify some connectivity between the PCs and the default gateway, etc., etc. And then we're going to move to step number 9, where we are going to look at the ARP table of each router and observe the difference between each step of the way. And then we're going to move to step number 10, where we are going to look at switch 1, where we are going to look at the MAC address table and see what the switch has learned so far from the devices that is attached to them. And then we move to step number 11, where we are going to disconnect the Ethernet cable from PC1 and try to connect it to PC2. And we can then observe the ARP cache, how it changes, etc., etc. We will then initiate a ping from PC2 to the default gateway to see if the ARP table have been updated or not. We then going to shut the fast Ethernet 01 interface on switch 1 and then try to figure out how long it would take for the ARP entry to actually be removed from the table. And then we move to step number 15, where we are going to enable the fast Ethernet 01 interface again and make sure that connectivity has been restored between PC2 and the default gateway. Once we are happy with all of that, we will then save the configuration, and that would be the end of the lab. Okay, now that we are ready to go ahead and jump into the configuration steps, it is your chance to pause the video right now and give it a go yourself. If you read the video description below, you will see that I included the lab objective and the lab task, as well as the IPv4 address table. I also have created a lab document for you to download so that you can challenge yourself by building the lab and go through the list of tasks on your own and whenever you want to. I also have included the lab setup ready to go for you to configure. And obviously, this setup is only compatible with Packet Tracer. And you'll see that I included a couple of labs. The first one is the pre-configuration, and the second one is the post-configuration, just for your own reference. So again, pause the video now or just keep watching. Okay, so going through the configuration steps, the first step is already been done. As you can see on the screen, we built the lab and is ready to go. The second step, we are going to configure each device on the network to change the host name. So I'm going to start with switch 1. So I'll click on it and then go to CLI and then hit enter, go to enable mode and then config terminal. And then from there, I can say hostname switch. Do the same thing for router 1. And then router 2. Now this has been done, we can then tackle step number 3, where we are going to enable the interfaces on router 1. So I'm going to go back to router 1. And then I would say on router 1, I would need to say interface gig ethernet 0/0/0. and I'm going to say description, and that is link to router 2. And then we're going to say no shot to enable the interface. Similarly to interface gig Ethernet 000 on router 2, I'll do the same thing. Interface gig Ethernet 0/0/0 description link to router 1 and no shot as well. Go back to router 1, and what I'll do, I'll go to interface 0/0/1, and I would say description link to switch 1, and I will issue the no shutdown command to enable the interface. Now that we've done that, we can then move to step number 4. And step number 4, we would need to say on router 1, show ARP. You can see that we don't have any data showing on the router. Let's examine the same scenario on router 2. We get the same result. So when there are no IP addresses configured on the interfaces of a router or switch, the device cannot participate in the IP-based communication, including ARP protocol. Since ARP is used to map IP addresses to MAC addresses, if the device does not have any IP addresses to resolve, there will be no ARP entries in the ARP table, and therefore no output from the show ARP command. In summary, without any IP addresses configured, the device has no need to perform ARP process, and therefore it will not have any ARP entries to display. So from that step, we move to step number 5, where we are going to configure IPv4 addresses. So what I'll do, I'll go back to config terminal, router 1, and I would say interface gig Ethernet 0/0/0, and I would say IP address 172.16.0.1, and the subnet mask is going to be 255.255.252. And do the same thing on the other side. So I would go to config terminal, interface gig Ethernet 0/0/0, and I would say IP address 172.16.0.2, and the subnet mask is going to be /32, which is 255.255.255.252. And then what I will do here, I will go to interface gig Ethernet 001, and I will set the IP address with 172.16.0.130, and the subnet mask is going to be /25, which is 255.255.255.128, and I would say no shot. What I would do now, I will go ahead and configure PC1 and PC2 with the same IP address. So I go back to PC1 and go to desktop, and from there go to IP configuration. And in here, we're going to say 172.16.0.131. And the subnet mask is going to be 255.255.255.128. The default gateway is going to be 172.16.0.130. And then go to the CLI and issue IP config/all. That will show you the physical address, which is the MAC address of the fast Ethernet 0. It will also show you the IPv4 address, the subnet mask, and the default gateway. So let's do the same thing for PC2. So PC2, what we're going to do, we're going to say 172.16.0.131. And we're gonna also configure the subnet mask to 255.255.255.128, and that the default gateway is going to be 172.16.0.130. Let's go back to the CLI and verify that we have the correct configuration in there. And we're going to say ipconfig space / all. And in here we can see the physical address and the IPv4 address, the subnet mask, and the default gateway. So let's go back to our router 1. And now let's move to step number 6, where we are going to verify that each physical interface is in the up state, and we can look at the MAC address as well that is associated to each physical interface. So what I'll do, I'll just go to the user exit mode. And I'm going to say show interface gig ethernet 0/0/0. I'm going to hit enter. And here you can see that the interface status is up, which is what we're looking for. And here is the MAC address of this physical interface. Let's do the same thing for interface gig ethernet 001. Again, it's in the up state, which is what we want. And here is the MAC address of this physical interface. Let's do the same thing on interface gig ethernet 000 on router 2. So I would say show interface gig ethernet 0/0/0. And here again, we see that the interface status is in the up state, and the MAC address is, as you can see on the screen, is there. So next, let's tackle step number 7, where we are going to look at the ARP table on router 1 and as well as router 2. So if I say show ARP again, and let's just maximize this. Okay guys, so if we were to examine the first entry, for instance, from the show ARP command, we can see that the IP address 172.16.0.1 is associated with this MAC address and is associated with this physical interface. Now, let's just hypothetically, let's look at this MAC address. Let's check if this MAC address actually belongs to this physical address or not. So this MAC address ends with 0C1B. So if I scroll a little bit up, you can see that by revealing the show interface gig ethernet 000, it will show you the MAC address of that physical interface. And you can see that it ends with 0C1B. So that matches accordingly. Similarly, with the second record, you can see that the second MAC address, which ends with B9EA, is associated with gig ethernet 001. If we verify that, you can see that the last byte of the MAC address consists with B9EA, which matches what we see on the ARP cache table. So what we are going to do next, we are going to move to step number 8, where we're going to verify some connectivity between PC1 and the default gateway, and between router 1 and router 2. So if I say ping 172.16.0.2, which I'm pinging the interface of router 2. So the first ping fails due to ARP request. And if I then reveal the ARP table once more, you will see that to get to the 172.16.0.2, we would need to use this MAC address as the header of the frame. And it has learned it from this physical interface, as you can see on the screen here. So let's check what is the MAC address of 000 on router 2. So if I do this and go back to here, you can see the MAC address that is associated with interface gig ethernet 000, it actually ends with 25CB, which exactly match what we see on the ARP table from router 1 perspective. So now let's go to PC1 and let's ping the default gateway, which is going to be 172.16.0.130. You can see that we get successful ping. And then if I go back to router 1 and hit the show ARP command, you will see that we also have learned about PC1. PC1 has the 172.16.0.131 IP address, and the MAC address ends with 8212. So if I go back to PC1 and scroll a little bit up, you can see that this is the MAC address of the Fast Ethernet 0 interface, and you can see that it ends with 8212. So step 8 and step 9 have been completed, and we examined both ARP tables in two different scenarios where communication has been initiated by the end devices, and we can see that the routers are able to learn the MAC address of each device that is trying to communicate throughout the network. So what we're going to do next, we're going to tackle step number 10. So step number 10, we want to go to switch 1 and have a look at the MAC address table. So I will hit enter, go to enable mode, and from there I would say show MAC address table. So if we look at the show MAC address table, you will see that we've learned the MAC address that is coming from each interface. So you can see that it learned this MAC address, which is coming from Fast Ethernet 01. And we know that PC1 is already connected to Fast Ethernet 01. So it learned that MAC address from this physical interface. And the same applies for the second MAC address. It learned it because a frame would be coming from the Gig Ethernet 01 on router 1. Okay, so you might ask me the question, how does the CAM table gets populated? So the CAM table, which stands for Content Addressable Memory, is also known as the MAC address or the Media Access Control address table in a switch, which it populates dynamically as devices communicate on the network. Regarding the actual process of how the table gets populated, when a switch receives a frame on one of its ports, it examines the source MAC address of the frame. If the source MAC address is not already in the CAM table, the switch adds an entry to the table. The switch records the source MAC address and the port to which it received the frame in the CAM table. This mapping associates each MAC address with the port through which the frame was received. If the frame is received with a MAC address that is already in the CAM table, the switch updates the entry to reflect the port on which the frames was received. This helps keep track of the movement of devices within the network. And we're going to go through that particular step in a moment. So in terms of aging process, so entries in the CAM table have a certain aging time, after which they expire if no frames are received from the corresponding MAC address. This ensures that the CAM table reflects the current network topology and remove stale entries for devices that are no longer active. Overall, the CAM table allows the switch to make forwarding decisions based on MAC addresses, enabling it to efficiently deliver frames to their intended destinations within the local segment. So if we then move to step number 11, what we would need to do, we would need to go back to our topology, and we will need to unplug the Ethernet cable from PC1 and plug it into BC2. And give it some time until spanning tree is start to forward frames from that port. So if I go back to switch 1, you can see that the physical interface Gig Ethernet 01, it went down and then it came back up again when we plugged it into the second PC. And if I go to PC2, again, we have configured PC2 with the same IP address, but obviously PC2 has different physical address. We then ping the default gateway from PC2. we would say ping 172.16.0.130. We get reply from the default gateway. If I go back to my switch and issue the show MAC address table, you can see that the MAC entry has been updated. Now you can see that this MAC address is coming from this fast Ethernet 01. This MAC address matches the physical MAC address on PC2, as you can see on the screen. If we then go to router 1, hit enter, and then try to reveal the ARP table. So you can see that the MAC address has been updated according to the physical address of PC2. So if I check that one again, you can see that this hardware address matches the physical address on PC2. So what we're going to do next, we are going to step number 14, where we are going to switch 1 and shut down fast Ethernet 01, which is the link that is connected to PC2, and we're going to shut that interface. So if I go to switch 1 and I go to config terminal and set the interface to fast Ethernet actually. Zero, 1, and we're going to say shutdown. So at this point, if I try to ping the default gateway, it will not work. Now, if I go back to router 1 and start hitting the show ARP command again, you can see that the age timer will only increase. You can see that the age timer is increasing. And if we were to look at how long the ARP entry would take until it times out completely and then the entry gets removed from the ARP table, that would actually depend on the network device and its configuration. However, in many cases, ARP entries have a default timeout period of around 4 hours. So what we are going to do next, we are going to enable the fast Ethernet 01 interface again. So I will say no shutdown. And then if I say show IP interface brief, you can see that this is in the up state. And if I go back to my topology, we can see that the link's still amber because of the spanning tree protocol. And to check this, I will cover this topic later on at some point in the future. But if I go and say show spanning tree VLAN 1, for instance, now it's in the forwarding. So if I go back to the topology, you will see that the link is green. I'm going to go back to PC2 and then start to initiate the ping again. And you can see that the ping is now successful. And here we have reached the end of the lab. So that's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. Stay curious, stay inspired, and until next, peace.